to provide us with a 20-kilometer rock that appears once per decade. But more importantly, the trajectory is very unusual. It's aligned with the orbit of the Earth around the Sun.
December 2025. Everything in the astronomy world flips upside down when scientists lock onto something wild. 3I/Atlas, only the third interstellar object ever spotted sliding into our solar system at a speed that shouldn't even be possible. But the real jaw-dropper hits when the James Webb Telescope picks up a steady rhythmic glow pulsing from deep inside its core, a type of light no ordinary space rock should ever be producing. Instead of dimming or breaking apart like normal debris, this thing gets 3 times brighter than expected with zero comet tail, zero dust, zero wobble, just a perfect machine-like rotation that feels way too intentional. Then the knockout moment arrives. Multiple research teams confirm a repeating thermal heartbeat firing off every few hours, followed by a wave of strange radio bursts that match no known natural pattern. If the data is clean, and so far it is, we might be staring at the first real sign of something built, not born, making its way straight toward our neighborhood. So what exactly is 3I/Atlas, and why has its sudden appearance sent the world's leading scientists into full-blown panic mode? August 6th, 2025. The truth starts unfolding. Deep inside the non-stop data stream coming from the James Webb, a group of NIR-spec operators catch something that makes them stop everything. The first infrared frames of 3I/ATLAS don't show a hazy glow or scattered dust like a normal visitor. They reveal a tight, concentrated light blazing from its center, bright enough to drown out anything surrounding it. The readings come back clean. No calibration issues, no solar flares messing with the sensors. Just a bold, white-hot pulse fading into bands of color, all centered around a nucleus no telescope on Earth can even resolve. Dr. Lena Markovich, the senior instrument scientist leading the Webb team, double-checks every log, reruns every calculation, and the numbers refuse to change. The emission stays steady, glowing at levels 3 times higher than any model says an object this size should produce. No tail, no flicker, no random flare-ups. Just a constant, unwavering beacon blasting through the void. Their internal chats start going crazy. Is this outgassing or something completely different? Archive checks kick off instantly, because whatever this thing is, it's not acting like anything space has ever thrown at us before. Hubble and TESS had already picked up hints earlier that summer, faint signs of an object shining way too bright, way too early, far beyond Jupiter's orbit. It was glowing long before sunlight could spark any normal comet behavior, but even those early clues looked weak compared to the crystal-clear, almost unreal images coming in from Webb. The operators knew instantly this wasn't some routine rock drifting through space. Something strange was happening deep inside this thing. The heat wasn't coming from the surface like a regular frozen traveler. It was rising from the core, like something was firing up from the inside, and whatever was powering it clearly wasn't following the usual cosmic rulebook. So the optical survey teams, from the Atlas group out in Chile to the analysts working Hubble's side, launched their own checks to make sure nobody was misreading the situation. Their first red flag? The brightness. By every standard, every chart, every model, 3I/Atlas was beaming almost 3 times brighter than anything its size should be at that distance. Light curve studies tracked it for weeks, and the results came back the same every time. A totally steady, dead-even glow with no dips or bursts, none of the flicker you get when a comet vents gas or spins across uneven terrain. Normally, comets brighten and fade like unstable fireworks, tumbling, shedding ice, releasing jets in bursts. But this thing stayed almost perfectly flat with a rotation period of about 6 hours, just enough for any major surface action to show up. But nothing ever did. Hubble's high-resolution imaging team dug even deeper, searching for that classic comet tail, that long stream of vapor that forms when ice burns off. Instead, They found the object wrapped in a tight, teardrop-shaped cocoon, like a smooth shield instead of a tail. It looked less like a natural plume and more like something intentional. Analysts pointed out another wild detail. Even out at 6 astronomical units, where sunlight is weak and normal comets stay quiet and frozen, 3I/Atlas was already glowing loud against the darkness. No model of solar heating, no outgassing scenario, no textbook physics could explain why it was behaving like this, or why it was heating up so early. Something about this object didn't match anything the solar system had seen before. These contradictions had the optical teams scratching their heads. This object was too bright, too stable, too self-contained to fit into any category they knew. None of the classic comet behavior made sense, so the researchers had to follow the only logical path left. If the light wasn't coming from the surface, then something deeper inside had to be doing the work. So the infrared analysts on the Webb team locked in on the time series data, breaking it down frame by frame, hunting for any kind of pattern in the heat pouring out from 3I/Atlas's core. And what they found wasn't just intense, it was organized. Every 4 hours, on the dot, the central glow swelled and faded in a slow, steady cycle that felt way too intentional to ignore. The pulse was clean, consistent, almost mechanical, with energy rising from the heart and rolling outward like waves from a controlled engine. No random flicker, no chaotic bursts, just a perfect rhythm repeating again and again. The data logs filled up with timestamps marking each rise and fall, all repeating with the same cold precision. Dr. Lena Markovich and her crew mapped those intervals against every variable they could think of: rotation rate, angle to the sun, orbital change, hoping something would explain the pattern. But nothing matched. The heat didn't line up with sunlight, didn't trace surface patches, didn't behave like anything driven by natural processes. It pulsed from deep inside, untouched by the object's spin or distance from the sun. To the Webb team, the pattern didn't look like outgassing at all. It looked like a heartbeat, something built, not born. That's when radio observatories from California to South Africa jumped into the hunt, tuning their arrays to 3I/Atlas to check if anything electromagnetic was hiding behind the optical and infrared signals. The Allen Telescope Array, under Dr. Kavita Rao, started combing through hours of wideband recordings, stripping out background noise, satellite interference, and atmospheric garbage until only the raw signal remained. And tucked inside that data, the team isolated something that absolutely did not belong. What the radio teams found was a faint, razor-thin pulse repeating every 4 hours, the exact same rhythm the Webb team had seen in the heat signature. It never wavered, never slipped, just kept firing on schedule like a clock that refused to miss a beat. Fourier analysis broke it down, and the pattern stood out like a blade cutting through static. A stable carrier signal way too precise to be random cosmic noise. Over several nights, the pulse stayed locked in. But here's the eerie part. Its timing shifted in perfect sync with changes in the solar wind, matching fluctuations tracked by space weather monitors. That meant whatever was sending it wasn't isolated. It was responding to its environment. Independent teams at Meerkat and the Hellberg Array confirmed the signal, knocking out the usual suspects like interference or Earth-based sources. The pulse kept showing up across hemispheres, across continents, across multiple instruments. And its consistency forced a question no one wanted to say out loud. Was this a natural phenomenon, or some kind of deliberate transmission coming from something that knew what it was doing? By mid-August 2025, the whole situation cracked open even further. Webb's live feed caught a sudden flare. 3I/Atlas brightened almost 40% in under an hour. TESS, still watching from Earth orbit, confirmed the spike instantly. Every telescope locked onto the object recorded the same jump. Not just in visible light, but in heat too. For a short window, the object radiated like something inside had straight up powered on. Then, just as fast as it came, the surge cooled off. But the baseline brightness never returned to normal. It stayed higher, like the object had switched into a new mode. That's when everyone turned to the orbit. Marco Michelli and the ESA's Near-Earth Object team ran fresh models, and the path they expected after months of tracking suddenly didn't fit the new data at all. Instead of coasting naturally, 3I/Atlas had shifted its trajectory, sliding closer to the solar system's main plane. Michelli's group went back and forth. Was this outgassing, a measurement glitch, or something way less familiar? But the math kept pointing the same direction. The acceleration didn't match any known comet behavior. And this time, they had the timestamps. The flare and the course change happened in the same window, linked like a move and a reaction. For the first time, the logs weren't hinting at randomness. They were hinting at a maneuver. Now the pressure hit a whole new level, because what kind of object changes course mid-flight, and for what reason? Out here near the edge of the ecliptic on August 18, 2025, Webb's NIR spec instrument passed the baton to the spectroscopists. Carrie Lee's group at Johns Hopkins took command, pulling in the raw spectral data from 3I/Atlas and breaking it down line by line. The usual comet signatures were there: water ice, carbon dioxide, all the standard stuff. But sitting on top of those familiar markers were lines that made zero sense. Several absorption features refused to match any known database on Earth. And when they examined the reflectivity profile, things got even stranger. It hinted at metallic alloys, some resembling rare earth mixes usually used in high-level manufacturing here at home. Then came the detail that had the whole lab going silent. Buried deep in the data were spectral features that lined up with theoretical quantum materials, the kind that exist in physics papers but have never been seen occurring naturally anywhere in the universe. To the team, the math didn't point to random cosmic chemistry. It pointed towards something that, on paper, looked engineered. By late August, access to raw telescope feeds started getting restricted. NASA and the ESA pushed out internal memos citing planetary security, tightening who could see what. Behind the scenes, the SETI working group, run by a coordinator whose name wasn't even on the documents, debated whether they should try sending a message to 3I/Atlas. After a tense vote, the decision tipped, and the transmission went out. A clean mathematical greeting, prime numbers, the periodic table, basic universal constants. Nothing threatening, just something any intelligent system would recognize. Then the moment no one expected dropped. 72 hours later, a narrow band signal came back, timed to the second of the original transmission window. The reply was warped and distorted, but the underlying pattern matched exactly what SETI had sent. Within minutes, agency officials locked everything down: the signal, the logs, the channels, shifting all communications to classified systems outside public access. And instantly, rumors exploded. Inside the scientific community, the mood shifted fast. Curiosity turned into straight caution. At the August IAU debate, the big four explanations, outgassing, jets, radiogenic heating, dust scattering, and mass changes, all started collapsing under the weight of the new evidence. Estimate errors got checked, rechecked, and torn apart by every team on the roster, but none of them could explain the chain of wild anomalies tied to this thing. Not one. And now, with the September flyby creeping closer every day, the pressure is sky high. Every instrument on every major scope is about to lock onto 3I/Atlas, hoping the next wave of data finally tells the truth about what we're really dealing with. Back on August 6, 2025, Webb recorded 3I/Atlas, pumping out infrared light 3 times brighter than any model predicted for something its size. That alone was enough to raise eyebrows, but what came next had scientists losing sleep. Over the following weeks, teams logged a pulsing heat signature coming straight from its core, a repeating radio signal with machine-level timing, and a sudden 40% brightness flare that hit at the exact moment its trajectory shifted. TESS, Hubble, and multiple ESA stations all confirmed the same facts. Nothing was glitched, nothing was misread, and once the spectroscopic analysis came through, things got even crazier. Rare earth alloy signatures, absorption lines not found in any natural catalog, and material hints that lined up with stuff only seen in advanced lab designs here on Earth. Independent reviews tore through every natural explanation on the table: outgassing, radioactive decay, dust scattering. And the International Astronomical Union's debate panel shut each one down after going through the evidence line by line. As of late September 2025, its closest approach is right around the corner, and every major observatory on the planet is gearing up for direct observation. One thing is clear: 3I/Atlas doesn't fit any model we have, and its pass by Earth is about to become a defining moment in planetary science, maybe even human history. Drop your thoughts in the comments, hit like, subscribe to the StellarDrift channel, share the video, and I'll see you in the next one.